In this video, we are going to be solving applied problems that result in systems of equations. And the example that we're going to look at here is one where we have 3 equations and 3 variables. We have 4 basic steps to solving one of these problems, but before we start these steps, I would read through the scenario and really think about the types of information that we're given. As you're reading through, the first thing you're going to want to be doing is defining what the variables are. Then you're going to think about what types of information do we have and organize it in a table. Next, you're going to set up the equations, report the augmented matrix that results, and then for these, go ahead and use your calculator to solve the system of equations. Finally, you're going to state the solution in a complete sentence with appropriate units. Let's look at this first example. A furniture factory makes and sells chairs, tables, and chests. Producing a chair requires 2 hours of construction, 1 hour of painting, and 2 hours for packing. Producing a table requires 4 hours of construction, 3 hours of painting, and 3 hours of packing. Producing a chest requires 8 hours of construction, 6 hours of painting, and 4 hours for packing. In a typical week, there are 288 hours available for construction, 200 hours for painting, and 200 hours for packing. If all available time is used in every department, how many of each item are produced during a typical week? The first thing we need to do is define our variables. And if you read through this statement, there's a whole lot of different things going on and a lot of words. But looking at the last sentence, oftentimes we can find exactly how we need to define our variables in there. Our last sentence says, if all available time is used in every department, how many of each item are produced during a typical week? And when we think about what our items are, the things that our furniture factory is making and selling are chairs, tables, and chests. This is how we're going to define our variables. Our x, y, and our z are going to be the number of each of these things: chairs, tables, and chests. You can see that I've written x is the number of chairs produced in a week, y is the number of tables produced in a week, z is the number of chests produced in a week. I would try to refrain from writing something like x equals chairs because that doesn't tell you what about chairs we're looking at. We need to be very specific and say we're talking about the number of chairs we're producing in a week. So don't do this. Don't write x equals chairs. It's not specific enough. Next, we're going to look at the different types of information we have, and we're going to organize this into a table. Now, on our table, we're going to make the columns of our table go with our variables. So our chairs were our x, our tables were our y, our chests were our z, and then we usually have a total. Looking at the types of numbers that we're given, if we read back through here, we have all these numbers about construction. So we have each chair requires 2 hours, each table requires 4 hours, each chest requires 8 hours, and so we have all these numbers about construction. We also have total number of hours for labor hours for construction is 288. So we can use these values to come up with an equation. And so I have a row that's all about construction in my table. For each chair, we require 2 hours of construction. So we're going to have 2 times x is the total number of hours that we use making chairs. Each table requires 4 hours, so our 4 times our y is the total number of hours used for making tables, and then 8z is the total number of hours used for constructing chests, and this gives us a total of 288 hours. So the sum of these 3 values gives us 288, and this gives us our first equation. So see if you can do the same thing for painting and for packing. You should be able to build a painting equation and a packing equation. Did you get 1x plus 3y plus 6z equals 200 for your painting equation and 2x plus 3y plus 4z equals 200 for your packing equation? If not, go back and look at those numbers. Notice how I have underlined all of the packing numbers in orange to try to keep the numbers straight. It's very easy to get them incorrect. The other thing that often happens for students is they have the columns and the rows switched. So I would be careful to always put the columns are your different variables and the rows are your different types of numbers, different types of values you're given. So we have construction numbers in our first row, painting numbers in our second row, packing numbers in our third row. Those 3 rows in our table of information gives us these equations, and we can take these equations and make the corresponding augmented matrix. Then we're going to use technology to get the final reduced row echelon form matrix. Instructions for this are in another video, but basically you're going to enter this augmented matrix into your calculator as maybe your A matrix, and then you're going to tell your calculator to put it into RREF form by doing RREF of that matrix A. And when you do, you're going to end up with the matrix where we have 1s on the diagonal, 0s everywhere else. This is a matrix in RREF form. And then over on the last column, this column tells us what our values for our x, y, and z are. So we get x is 32, y is 24, and z is 16. And remember that we get these values because if each row in this matrix tells us an equation. So if, for instance, I look at this bottom row, this says 0x plus 0y plus 1z equals 16. So the 0x and 0y, those are both 0. And so it just basically gives us z equals 16. The last thing we need to do is state our solution in a complete sentence. Our sentence should look something like, the factory should produce 32 chairs, 24 tables, and 16 chests each week. That's it for this video. Thanks for watching.